So once again, good morning, namaste and vanakkam. And um, we have finished two major parts of our discussions. One is on an introduction to the idea of maintenance. That was the first part, maybe the first couple of lectures. And then we discussed about the idea of management, okay, which we had over an extended period. Of course, what I have shared with you is more of a, not even a bird's eye view, perhaps a satellite view kind of the subject of management. Today, we will go to the bridge connecting us with some of the methods that are used for maintenance management. So the last part of our discussions in this course will be about the methods used for maintenance management. So we're going to have a bridge discussion today and maybe the next couple of classes on maintenance performance evaluation. I hope you understand, because in our definition of management, we had stated that step number one, management by design. Okay, step number one is state what you want to do, why you want to do, and how you want to do. So the answer to the question, state what you want to do in maintenance management, consists of the performance evaluation systems, because basically the performance evaluation systems will reflect what you are doing, what you will have accomplished, and what you wish to accomplish also. So that is the part. And then of course, how from the operational point of view will consist of the methods that we will have to study a little later. So that's the logical connection. Okay, so we're coming down from the mission and vision to the objectives, which we have discussed earlier. I hope all of you will recall the objectives: maximize availability, maximize safety, minimize downtime, and so on, minimize cost, maximize resource utilization, resource engagement. So many, minimize inventory, spare parts inventory. So there are many such objectives that are there. So we will look at the idea of goals today, okay, in the performance evaluation systems. Of course, we have to set the goals based on our performance expectations. And also there are, in some cases, there are some standards also, there are some standards of work which are available. I'm not sure about India, but I am aware that they are available in the United States. Especially, I've come across standards in their defense systems, maintenance standards in their defense systems, including work standards of craftspeople, the maintenance craftspeople. They say this kind of a task should take not more than this much of a time. They have something called normal time, standard time, and so on. Okay, so there are such standards available. As I told you, I'm not very sure that we have such standards in India. In fact, I feel we may not have standards to that level of precision in terms of maintenance work. We do have material India has very good material standards. Work standards, there are industrial engineering studies which have given some work standards, but as I mentioned just now, I'm not sure about the work in the context of maintenance engineering has really been documented in the form of standards. Okay? There are some good materials available, and you can sort of read them up in the internet also. You may recall a point I had made earlier to you. See, when it comes to undergraduate education, experts suggest 5 to 10% of learning to be self-learning and peer learning. Whereas when it comes to postgraduate education, which is our context, the experts have recommended 25 to 33%, 1/4 to 1/3 of the total learning in a course would be good, will be effective if the student puts in self-learning and peer learning. So that's why I've given you some suggestions as to what you can learn on your own. And of course, when you do your PhD, more than 90% will be your own learning. The supervisors and the research committee or doctoral committee members will assist you, but the maximum amount of learning will be through your own efforts. So that's sort of non-linear curve of extent of learning on the y-axis and the program you're in, undergraduate, postgraduate, a PhD program on the x-axis. So please do learn about some maintenance standards if you can have an opportunity. They are available on the net, and I would like you to search and locate them. And in fact, one of you or even two of you can pick up maintenance standards as a topic for your final presentations, which should come in over the, say, sometime during the next 2 weeks. So you have enough time. Towards the last week of November, we will have some of the presentations from you for this course, okay? The visual presentation, that is the slides, the content, how you organize your thoughts and how you represent them visually, and also your oral presentation, both will be important. I hope you appreciate that even when you start working, both become important. How you express yourself orally, how you express yourself in terms of your body language and diction, and also visually through slides. That is for your own development as a professional. These aspects are important, okay? And I would like you to pay attention to them. Ideally, it would have been great had we been in flesh and blood together, because in that case, I would have given you feedback straight away and constructively. All of you would have been able to get some idea of what happens in presentations. But this is about the next best we can do now using the online mode of interactions. Okay. So can we go to the slides, please, Srinath? Yeah. Yeah. Great. You can increase the size. Yeah, that's good. That's good. That's very good. Yeah. So I'm starting off with maintenance performance measures and metrics. The basic reference for me is a very nice book. It's an old book by a Japanese author called Sohei Hibi. Okay, it's called Sohei Hibi, and Hibi, Hibi. I'm not sure whether you can get that book nowadays. By chance, I found that book in a book exhibition many years ago. I think it was way back in 1990, if I'm not mistaken. Okay, that's 30 years ago. I could locate that book. It was one of the very good books on maintenance performance measurement. Even today, I feel I do have some idea of what's available. I would still say Hibi's book is really very good in this subject. Okay, if I want to draw a parallel, it's something like in India we still, I mean, I say still in a positive sense, we continue to cherish the older texts, spiritual texts. We say Bhagavad Gita. So it's a few thousand years old, but we still say it is very useful. And very often colloquially we draw the metaphor, no, this textbook is the Bible in the subject. So if you ask me personally, I would strongly recommend Sohei Hibi, Sohei, Sohei, Hibi, Hibi. He's an authority on maintenance performance evaluation. He has written a few books, and this one on maintenance performance measurement, personally, I would recommend as the Bible for maintenance performance evaluation. Yes, we can always identify something more than what Hibi has presented. There are some limitations in what we can understand from what he has expressed in the text, which we will discuss today. I'm sure you will have questions coming up. My dear friends, please feel free to ask questions, because if you do get some doubts on what we are going to discuss today, the best way is to sort that out. Even I cannot claim a complete understanding of every term that has been used in the performance measures. So we will have to discuss and try to zero in on what something could mean. But I have a good understanding. Okay? So I'm giving you that, I'm sharing with you that caveat so that you also know that I may not have 100% understanding. I can tell you that I'm probably, in my estimate, I'm about 98% understanding of the terminology and what he is trying to say. Sometimes, the translations from Japanese to English will suffer some distortions. Whenever we translate any language to another language, there'll be some distortions. So maybe that has creeped in that Japanese to English translation. That's my guess. And then we are interpreting the English, so you will have further distortions also. So with that caveat, I'm beginning this discussion, and I'm confident that all of you will enjoy this discussion, because this takes us to the meat of our work in maintenance management, the performance of maintenance. Of course, please understand, later I will also share with you the bridge between the engineering and management, maintenance engineering and maintenance management. There are some texts. We are not going to, we will not discuss that in our class, but I will share with you those materials so that it will be useful for you as a checklist. And those materials are also from HEBE. Okay, I think you will find them very interesting. A lot of very useful engineering content given in the form of summary tables in HEBE's book, as to what you do, or what you check in the engineering practice of maintenance. Okay? So that way, it's a very nice book which blends both engineering and management. Okay? And you will be able to understand how to connect the management performance measures with much of the engineering that is done. So that's not at all difficult. That if you start reading the book, within 10 to 15 minutes, you'll get a hang of what he's trying to say. So that will not be difficult. Okay. There are some other books also. I will send you the references. I have some 4 or 5 good reference books connected with maintenance management, reliability centered maintenance, design centered maintenance, and so on. So they will be useful to you. I'll give you the references and you can try to look them up. Of course, once you are in campus, you're welcome. I'll also share with you the books. You can see what they contain. I'm not sure whether the department will be able to arrange for the books for you. That I'm not sure. Maybe we'll discuss with the Department of Biotech and get back to you on that. Okay. So with that introduction, we will begin with the maintenance performance measures or metrics. That's why I put a stroke there, measure stroke metrics. Okay. The first performance measure in maintenance, you would have guessed this also, that is, we want to avoid emergency failures. I hope all of you agree. One of the good aspects of maintenance is your maintenance is considered good if you don't suffer any emergency failure over a period of time. So whatever maintenance performance measures or metrics that we are going to discuss are in the context of some period of time. It may be a week, it may be a month, it may be a quarter, 3 months, or it may be a half year, or it could be annual also. Okay. So we are going to examine these measures over some period, and I'm sure all of you appreciate why we are looking at a period, because it gives you a reference for comparisons across periods. So if I do the maintenance performance evaluation measures, say week by week, you can compare a subset of weeks with another subset of weeks. I hope I'm clear. So you know which direction of work performance you are going into. Okay, whether you're improving your work performance, or it's stationary, not much change, or things are deteriorating. So you'll get an idea. So that's the reason we take some period. I've not specified the period explicitly in the slides, but that's why I'm sharing with you, so that you will hold in your mind that whenever you are working with maintenance performance measures, please keep a period at the back of your mind. That's important. Am I clear, please?
Yes, sir.
Yes, sir.
Okay, very good. So keep a period, and depending on this context in which you're working, you can use your best judgment and decide whether you want to have 1 week or a fortnight or a month or even a quarter like that, or bi-monthly, etc. That's a matter of judgment. Okay? And that you will know when you start working, you will have an idea. For example, if the frequency of maintenance is very high, you might prefer a week over a month. I think you understand what I'm saying. And that is a matter of judgment. If the frequency of maintenance is not so high, but significant for you, then you might prefer a month as the period of study. Okay. So the first one, as you might have even guessed, what would you understand if the emergency failure are the number of emergency failures are high in your opinion, what would you comment about the maintenance of that system?
The maintenance is not good.
Yes, Aryaman, correct. The maintenance is obviously poor if the emergency failures are high. So this is one of the early measures that was used, So we are talking of measures that have been practiced since after World War II, roughly. I mean, if you want a thumb rule, and some of them even during World War II, some of the measures came up during World War II, especially when you take the aviation standards connected with maintenance work. You'll be, I mean, this is general knowledge for you. It will be very interesting to know that people are tracking availability of fighter aircraft and bomber aircraft. I'm sure you understand why, because it is of tactical importance to the air force of that country. That's why I told you a lot of the developments happened in the United States at that time, to some extent in Germany also. They were tracking all these figures, how what is the availability of planes. And there is some text. This is in a different text. It may not be in Hibi, but there are other authors who have commented. People are worried because the availability of sometimes the fighter aircraft was as low as 30%. So you have about 100 fighter aircraft, only 30 are available for full functional deployment. I'm sure all of you will recall the term full functional use, full functional deployment, etc., which we had discussed earlier. All functions are available. So now you can understand the concerns of these performance measures. So obviously, this means a very important point for you to take note of. You must document maintenance performance. Very, very, very critical. Don't hold it only in your head. You will not be able to sort it out. And as I told you, even spare parts inventories sometimes can run into thousands. There's no way anybody can remember what's happening. Critical inventory, vital and A-class inventory, you might be able to hold in your head, because of your own practice and your concerns with that inventory. So some spare part is vital and it's A-class, you're really worried about it, So you want to see to it that you don't goof up on that inventory. Now you can imagine, and there'll be so many job orders coming into the maintenance department, asking for maintenance to be performed. Now this is over and above the scheduled maintenance which you do in consultation with the operations people. I hope all of you are able to understand. Ordinarily, with the regular operations people, even in a hospital, you will work with them, you will converse with them, you will discuss and work out a scheduled maintenance. You'll say, look, on these particular days with this frequency, we'll come and do basic check, or we'll do some alignment check, or we'll do some basic lubrication, oiling and greasing, etc., so that the equipment is proper. We'll do some cleaning and so on, isn't it? That you will, I mean, you can't go at your will. It's not fair. So if it's a manufacturing plant, you will discuss with the production shop floor manager, saying, sir, we would like to do this schedule maintenance. You have your production schedules. Can we sort of look at what we can do without having any negative impacts on your production schedules? So this kind of a discussion is very often necessary. And these are also sources of interpersonal conflict connected with the politics in the organization. If you as the chief of maintenance and the shop floor manager as chief of production are very good friends, you may be able to sort out many things across the table. But suppose that person doesn't like you, or you don't like that person, or both of you know that you don't like each other, the entire game changes. I'm telling you this because you must not isolate away the human relationship angle in management. I mean, this is fairly obvious. What I'm telling you is obvious, but unfortunately, what is obvious is missed. As they say, tongue-in-cheek, people remark, common sense is uncommon. It is like that, So you also need to see to it that your relationship with the staff are good. And you'll sometimes find very funny stuff, both you as the chief of maintenance and the chief of production are very good friends, but your workmen on two sides may not be very good friends. They may be at loggerheads with you. So you'll have an extra problem to tackle in that case, how to see to it that the work moves on, progresses effectively. So that becomes a challenge. So in that case, you have to use your friendship with the chief of production and try to sort out matters when conflicts happen. And you know what happens usually on the field, people won't give full information, and they'll be having something in their mind. Okay, I want to fix this guy, let this guy come to me, let me see, dekhunga, main dekh lunga main. That kind of an attitude will be there. So all this is the environment in which we are trying to talk about performance measures. I hope you are able to get this point. You cannot isolate performance measures from the human context in which they are there. So there's a lot of discussion to be had when you're dealing with the work of maintenance. Okay? And don't forget, maintenance time is counted under downtime. I hope all of you will recall that. When the machine is not running, it is downtime. All right, we can argue that, look, we are bringing back that machine to health. So we are not doing something negative. We are sort of doing something positive. But that argument is only can go so far. Beyond a point, it will not cut ice. It will not be convincing, because from the production perspective, it is downtime. That means money not being earned. So you have to keep all these things in mind and do that balancing act. Okay. So now we were just discussing about emergency failures and how emergency failures and the frequency is going to tell you something about the status of maintenance. As Aryaman was pointing out to my question, if the emergency failures are high, in your opinion, in your judgment, you will infer that, look, something is going wrong with the maintenance. Otherwise, why are we having such a high proportion of emergency failures, and among the total failures? I hope you got the point. If you take a period of time, let us say if you take 6 months, you'll have a set of failures of equipment, okay? A total set. All of them are not emergency failures. Some may be minor failures which you can attend to, and within half an hour the machine is up and running, or even less than half an hour. Emergency failures typically are associated with intensive work on the machine. Issues that you can't solve within half an hour, and they will involve a lot of that fault tree analysis, etc., which I mentioned earlier. So you'll have to trace the fault. Why is such a failure happening, and so on. And it does take time. I'm just giving you a very nice example. I was mentioning that I shifted home last week. Okay, so yesterday the air conditioning people had come to install the AC from they've taken it down from my old home and brought it to my new home, and they were installing. And of course, they did the installation, did the check, and they found that something was wrong. And then they did all the tests. It took a little while for them. It took about half an hour, but they were obviously skilled technicians, and they could locate that, sir, there is something wrong with your motor. The compressor is working fine, but there's something wrong with the motor. So then they advised me to change the motor. Obviously, something must have happened during the transport of the air conditioner. It was a working air conditioner. So like this, we can have problems. For me, it's not an emergency failure, because nowadays the weather is quite nice in Chennai, because it's raining and it's fairly cool. Nights are pretty comfortable, and if you put on the fan, you have to have a blanket, because it is slightly cool. It's not cold, it's cool. So that way it's not an emergency. But imagine that in the peak of summer, the same air conditioner and a failure would have meant an emergency, depending on what we are talking about. And remember, in some contexts, air conditioners are critical, vital, like in certain clean rooms, etc. Air conditioners will be vital. So failure could be a serious failure, emergency failure. Okay. So this is a lesson. Please do not forget, in a period of time, say 6 months, you'll have a set of failures, a number of failures. All of them need not be emergency failures. Okay. So you can do emergency failures in terms of either a ratio of number of failures, number of emergency failures divided by total number of failures. if you have documented it that way, or as the screen shows, it can be number of emergency failures by total operating time. Okay, please mark the word operating time. So there is a total time available 24 hours in a day. All the time is not operating time. I hope you got this point. Okay, so you have to be very clear about the operation policy of the plant or of the machines. Are you in a situation where the machines theoretically have to be operated all the time? Like some equipment have to be operated all the time. I'll give you simple examples. Say cameras that are installed for security. Now you would like to have those cameras operating all the time, isn't it? And there are, like I told you, there are some specific lab equipment which have to be running, laboratory equipment, including air conditioners, which have to be running all the time. Sometimes there are computers that have to be running all the time. So there are some things which define operating time. So while the denominator reads simple as operating time, I want you to understand the nuances. Operating time does not mean all the 24 hours. It depends. Okay, it depends. And please don't forget the point I made earlier. The best two-word answer you can give to any question asked of you is it depends. Right? I think you got the point. Because you may have to get into the nuances of the situation, the finer aspects of the situation, and then take a call. So I hope this point is clear, that operating time need not mean all the time, but the time that you have scheduled the operations to take place. Even in a shift, it can be shift by shift. Okay, so sometimes the machine is running when the shift changeover happens in the plant. Sometimes the machine is shut down and the next person comes and starts operating. That is very situation dependent. Okay, so that is why. So the number one measure, maintenance performance measure or metric, a very simple one but a very useful one, is number of emergency failures by total number of failures or by operating time. And I defined operating time. This also means that you have to have a definition of what constitutes an emergency failure, which you will have documented. I hope this is clear. Be very clear as to what you will consider to be an emergency failure. Okay, that is important. Okay, fine. The second one is emergency failure intensity ratio. Okay, now you can see here we are shifting from number to the time standards. So the ratio says downtime due to emergency failures by operating time. Please do recall our discussion some classes earlier about the components of downtime. Can you recall the components, please? Anyone? What were the components of downtime? I drew it on the board, if you recall. Remember, different times I have marked on the time scale. Just go back on your notes and identify those times. Anyone, please?
Hello, sir.
Yes, Rishabh, thanks. Yeah.
Discovery of the failure.
Yeah, the first one is, Rishabh, be very careful. Before discovery, there is another time, which I told you is uncertain. If you look at the left-hand side, what is the leftmost edge time?
Event
that is one. Event, the failure event, Rishabh. Yes, okay. Now, I hope all of you are able to understand. Rishabh, is it necessary that the failure will be discovered immediately after it occurs?
No, sir.
Not necessarily. Do you agree? Like I told you, the air conditioner example in my home, I just told you, it was working in my IIT staff quarters, IIT Madras. I take it to my home and I discover, after the technicians check the parts of the air conditioner, and then they tell me the motor is faulty. I mean, somewhere in between the event one has happened, correct, Rishabh? The failure has happened somewhere before that discovery. Am I correct?
Yes, sir.
So that is uncertain, you don't know. So the discovery time is when you're registering. Go ahead, Rishabh. Go ahead.
Then fault located.
Yeah, then you take time to, once you discover the fault, you trace it, you locate the fault. Yeah, good. Then,
Sir, maintenance crew arrival.
yeah, maintenance crew arrival. Very interesting. Right now the air conditioner is not working. So the concerned people will come back today and do the air conditioner. I'm giving you a good example now from my own personal experience. So that means many hours of are lost for me. But the only solace for me is it's not it's an air conditioner now is a desirable for me. It's neither vital nor essential. So ठीक है, कोई problem नहीं है. I don't have a problem. Are you understanding? But this is a good example of the time between discovery of fault, identification of fault, the identification of fault and the crew arrival time. Then go ahead, Rishabh.
Then the machine repair. The
Then
time
the
between.
actual repair time that is taken, and then
machine handover.
Testing time.
Yeah, testing time.
Rishabh,
Machine
don't
repair.
forget, you're not going to hand over immediately. We will not hand over the machine immediately to the production or the operations people. We will do the check, we'll do the test, and then say, okay, now it's okay, you can take the thing, isn't it? I did mention to you, many years ago, I was a graduate engineer trainee in Air India, in the Santa Cruz facility. So I still recall the first day was very interesting because I went, that was about the first opportunity for me to go very near an aircraft, touch it, go inside, etc. I've done it earlier because when I was a small boy, my father had taken me inside. But as an engineer, this was very important, So I was very excited in the afternoon. I went in that facility, So there, I just learned that a pilot will not be able to do anything with the aircraft until the maintenance, that concerned maintenance officer or the technical officer signs that the aircraft is airworthy. Okay, so only after that it is effectively telling the pilot this, boss, abhi theek hai, you can use it, So this handover is a very important thing for all of us, and you will hand over only after you have done the checks and you are satisfied that the machine is in what you call as full functional deployment, its full functional capability can be used. So that's why that takes time, testing time. Then you hand over. And very often you will understand that even after handing over, your maintenance staff will remain there for some time. You can answer, why do you think that happens? Why is it that the maintenance staff remains there for some time, even after testing and handing over? Yeah, Rishabh Bhaiya, go ahead. Yeah.
Yes, sir. So for confirmation to our side, from our
Yeah,
side.
sort of. It is both sides confirmation, The operator is also saying, acha, theek hai abhi. And you're also saying, okay, fine. So you are confident that the machine is working in a reliable way. This is the point. Okay. So many components are there in downtime. Now you can understand downtime from emergency failures divided by total operating time. That's called the emergency failure intensity ratio. And please remember what I told you some time ago, documentation is a must. You must document all this. So sometimes you might wonder, arey, itna form fill karna hai hame. I mean, yes, that's right. It can be a little inconvenient. People can be feeling inconvenience, but you have to do that for collective good and over the long run, because only then you will have a grip on what's happening in the plant, in the system. So without documentation, human memory will fail very badly in these cases because of the variety of maintenance events that can happen. So common sense should tell us. So you have to have standard documents created. And very often, let me tell you, when you take charge of the maintenance function, you may have to create the documents also. You may have to design the documents. Okay, so that's another topic for any one of you to talk, to present at the end. maintenance performance documentation. It's a very nice topic. What are the forms you will create? What data you should collect in those forms? How much of the data can be automatically collected? See, today, because of the technology that is available, I'm very sure that you will all automatically know a lot of the data can be collected automatically and fed into your computer straight away. Okay, so you can sort of work on the data real time online. Okay, it's not necessary that a person has to go and collect the data, etc. So you'll have to work out those schemes. That responsibility will be yours when you take charge of the maintenance. And often what happens is, when you take charge of the maintenance function from a previous officer, one of the early tasks for you would be to review the formats that are available for data collection, because you may have your own ideas, which can augment what would have happened earlier. So even that is an important topic. The documentation formats, what data is collected, who will give that data, how do you verify that data, and so on. So while what I'm saying seems simple, but I can assure you that on the ground, this is a different ball game. Please trust me, it's a very different ball game on the ground, and sometimes just look at the number of errors that can happen. Can one of you guess one or two errors that can happen in the documentation? Common errors in documentation. Any one or two of you. It's common sense, you can easily identify. Yeah, go ahead, please.
So number like a decimal point could be 1 or 2 point here or there.
Correct, Aryaman. Even putting a decimal point could be done wrongly. Sometimes wrong data entry can happen, isn't it? That is, somebody has read 8 as 3, and then they'll write, if it is 81, they'll write it as 31. And sometimes they've read it correctly and they're registering it wrongly due to some lack of concentration. Not only that, one of the serious errors is not even putting the data after reading it. Then the workman will go and you will be sitting there and you will ask her, "Arey, kya hua yaar? Ye data nahi hai." Then he'll say, "Sir, bhul gaya, sir." Isn't it? So I forgot. So you will have very funny situations like that. So that's why I said what I'm saying is easy. It appears easy, but on the ground it's a different ball game altogether. Okay. So data entry could be wrong. Okay. Sometimes people even put wrong units. It's very sad. So instead of centimeters, by conditioning, they may put millimeters. And you say, what is this? Something is not gelling. Then you'll ask, "Ye sahi hai ki nahi? Ye theek hai?" You'll ask the person. And that person will confidently say, "Theek hai, sir." But you'll say, "Nahi, kuch theek nahi lagta." You'll say something is not seeming right. So you'll very often have to do some checks on this. And very often, please understand, you'll have to take readings of acceleration and vibrations, pressure readings, flow rate readings for fluids, etc. Just imagine how many mistakes can happen there. Careless mistakes. I mean, oversight, not that deliberately somebody is doing. I mean, I'm sure as students you will know as much as I know. Don't you agree, in our own examinations, how many times we make careless mistakes? And then you say, "Arey yaar, I knew the damn thing. I've made a careless mistake. Marks gaya." Isn't it? But this is real life. It's not an examination. Examination is also real life, but in the sense that there's a difference. There you're working for marks and grades. Here you're working for your actual performance. So you have to be very careful on that. So although I'm discussing these simple performance measures, I want you to appreciate the kind of details that go into it. The documentation, the correctness of the documentation, the frequency of the documentation, the formats of the documentation, all of which will be in your charge when you take charge of the maintenance function. So please do take a look. I mean, we're not going to discuss all that in our course, but this is what I meant by some self-learning and peer learning. We will learn from each other. if one of you will present on maintenance performance documentation, others will also learn something from that friend, isn't it? So somebody may somebody may give a presentation on reliability centered maintenance. You learn that way. So that's the advantage of these shared presentations, and it's a good thing for you also, because it's a part of your profession later. You will have to present. So all these chota mota presentations will add up to your confidence in making presentations. Okay, so you have to look at it from that perspective. So that's important. Okay? So I hope you've understood emergency failure intensity ratio, which is downtime from emergency failures by operating time. Okay, and from the documentation you will know what is the downtime due to emergency failure, because you will have already classified emergency failures, and your documentation will show you the downtime. Okay. Then third one is trends in downtime. As you can see, weekly or monthly downtime, the downtime plots by equipment type. So for each equipment, you do downtime plots. It could be a bar chart typically, and if it's a continuously operating equipment, it could even be line charts. So we'll be talking about charting, how to make graphical presentations when we go into the basic data analysis techniques, just 2-3 lectures away. Okay, so what kind of a chart or a plot or a graphical representation for what kind of data, we will study that in due course. Okay, so you can create weekly or monthly downtime plots by equipment type. So you will classify equipment also as vital, essential, desirable equipment, and you can do the downtime plots. Okay, so this is very important. So here is a question for you. You're working in a large hospital, let's say 350 beds or 400 beds, fairly large hospital, okay, quite large. Is ambulance vital, essential, or desirable?
Vital.
Vital.
Vital. So how
So
do
essential.
you, Bhaiya?
So it is vital for life.
Correct, Akhilesh. Yeah, very good. Go ahead, Akhilesh.
So vital for life, and the presence of ambulance can save life.
Correct.
Because
yeah.
Yes.
No, but why did you say in vital, essential, or desirable? You classified it as essential, whereas other friends had said vital. That's what I was trying to
Sir,
find out.
because in some other lecture we got differentiation between essential and vital as
Correct.
essential for life.
I'm not so sure. I'm not able to understand you, Akhilesh. See, vital means without that thing, okay, without that resource, you cannot perform the work. Okay. Now listen carefully, Akhilesh. I see some meaning in what you have shared. Without the ambulance, can the hospital perform its work?
Yes, sir.
The others who said vital, watch out for this. Please watch out and answer the question also. Even the others can attempt this. Can we perform the work of the hospital without an ambulance?
Yes, I think so.
Yes, we can.
No, sir.
But
It depends on the area.
Yeah, very good. What will be the quality and effectiveness of the work or efficiency of the work if you function the hospital without an ambulance?
So poor quality.
Your quality will
not
be
so good.
lowered, correct? No, because I see merit in Akhilesh's point. Definitely I see merit, but personally I would still classify ambulance as vital, although from a pure abstract angle Akhilesh's point has merit. We have to look at it. Can I carry on the core work of my hospital in terms of treatment, in terms of surgeries, etc., without an ambulance? The answer is yes, technically yes. Okay, so we're talking of the speed with which a patient is brought to the hospital. Basically that's what we are trying to do. So if you're looking at it from that point of view of abstraction, it's closer to essential, although our heart would say, sir, it is vital, sir. I hope it's certainly not desirable. Okay, but that is why in large hospitals you will always find 2 or 3 ambulances, not just be one. It's like that, I told you about that fighter aircraft in the airfield in World War. So it will not be one, there will be several, because only a proportion of them will be available when they are needed. Okay, so that is the point. So you got that idea. So trends in downtime you can plot from that aspect also. I asked you that because from that ambulance point of view, this will be very interesting, the downtime of the ambulance, because there are many occasions where I have gone to hospitals for admitting somebody, either a family member or a friend, and I have observed on some occasions that the staff will say, sir, ambulance is not available, there's some breakdown, so we'll have to get an ambulance from an external service provider. And incidentally, there are external ambulance service providers also nowadays. So that's why this downtime plots will give you by equipment type. This equipment type is very important, because that way you can track every vital or essential equipment as to what's happening on the downtime. And can anybody guess why these plots will be useful? Why will those downtime plots be useful to you over a period of time?
So for better visual, we cannot go on and read data, but we can interrupt graph very.
Okay, you are talking of interpretation, Aryaman. I'm going one step further. I do agree with you. A visual, see, please understand, a picture is worth 1,000 words, people say. And another thing, very often when I interact with students, I do make this point. Is it possible to bullshit with a picture?
Yes.
Very difficult. Very difficult. Avinash?
So there could be multiple interpretation of the same picture.
Correct, that is true. But what happens, I mean, that's a good point, but very often in a given context, pictures are interpreted in a unique way. Do you agree? When the context is
yes,
fixed,
sir. In a context, yes.
Yeah, when the context is fixed, the picture, it's like our traffic signs, on the road. Context is very clear. You don't misinterpret a picture. Correct, Avinash?
Yes, sir. Yes, sir.
Yeah. So I was talking of a context, although your point is well taken. People can. So in a context, if you ask me personally, it's almost impossible to bullshit with a picture. So I stress upon pictorial communications, and even in Japanese management, if you read about Japanese styles of management, they emphasize graphical and pictorial representations. They really emphasize that. Because, and even on many of the shop floors, if you read about the famous TPS, Toyota production system, it's very famous, okay? You can Google it, and within 2 minutes, if you read it even for 5 minutes, you'll get a hang. Oh, what are these guys talking about? So the Toyota production system also, when you read that, you'll understand the emphasis they place on pictorial representations. Because it's very nice when you work with pictures. As Ariman rightly said, and if I add what I had mentioned about the context, a picture conveys something, but there's something more than that. What other than the clarity that the picture offers, anything else are you, can you identify anything else from the picture of downtime plots?
We'll know the areas of improvement.
Pardon?
We'll know the areas of improvement.
Correct. That is one, Mohan Raj. Agreed. Anything else, Mohan Raj?
We'll know the direction in which the trend is going. It's a positive or negative.
You came very close, Aryaman, actually. You came very close. Do you agree that picture will show some patterns of the downtime?
Yes, sir.
Because after all, x-axis what will be there on the x-axis, Aryaman? In downtime plot, what is that x-axis?
Time.
Time. So across time, you will be able to observe some patterns. So you might be able to observe patterns like, array, this thing is happening roughly with a frequency of 3 weeks. Are you understanding? If you are able to observe that a particular phenomenon is happening approximately over a period of 3 weeks, your anticipatory work will become much better. You may recall our discussions. One of the finest aspects of management is anticipatory management. You're able to anticipate something and take precautionary measures. So that becomes very strong when you do this, when you do these plots. So you can see from a simple plot, like a downtime plot, you get, all of us derive so many benefits in terms of understanding equipment work and equipment performance. That is the advantage. Okay. The fourth one is trend in number of maintenance manpower. So you can have daily or weekly plots of crew work. So electrical, plumbing work, oiling work, etc. So you can classify the workmen and do the trends of work. Okay, like that, manpower. It's a simple plot, graphical plot. The last one for today, material cost per repairman. So in a period of say a month, you look at the total repair material cost, because that you'll know from your inventory. How much of inventory has been drawn for maintenance, correct? So material cost you can have, and per repair man, total repair manpower. So per person, what is the material cost? That also gives you a clue about what's happening on the maintenance performance. Okay. So these are the set which we are discussing. We'll move faster. Okay. So today we have completed. We'll meet tomorrow. Tomorrow's Thursday. So 10 to 11. Bye, guys.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.